This is our Yellow Light project by Tim Niemann, Gabriel Nissen, and Marco Melika. In Lesson 1, our first introduction to physics, we learned about reaction time and its properties on the road. We also learned how it varies between people and what could increase or decrease it in certain individuals. Reaction time is not used in stop-or-go equations, but rather helps calculate the dilemma or overlap zones at an intersection. Since reaction time can vary so much between drivers, intersection engineers must take great caution when designing a safe road. As we learned when using the spreadsheets, it is difficult to create a road that has an ideal overlap zone.
So in 1-2, we learned about measurement, and we learned that detecting and reducing errors is one of the most important things to do when taking measurements in order to get both accurate and precise results. The best way to detect and reduce the amount of errors in a measurement is by conducting many trials and also being knowledgeable on the topic. By being knowledgeable on the topic, you should be able to tell if you're significantly off in your results.
In 1-3, we learned about velocity. Velocity is very important to consider when designing an intersection because velocity is in both the go zone and stop zone equations. So changing the velocity will always affect the size of the go zone and stop zone in some way. A designer will try to change the velocity in a way so that he can eliminate dilemma zones and create overlap zones. Acceleration, like velocity, is in the stop zone equation. However, acceleration is not in the go zone equation. So changing the acceleration will always affect the size of the stop zone, but it will never change the size of the go zone. Of course, anyone designing an intersection will have to take this into consideration.
Negative acceleration is acceleration of an object moving in the opposite direction that it was previously moving. For example, when a car applies its brakes, it is negatively accelerating. An intersection engineer must take this into consideration because a car that cannot efficiently brake or does not have the proper negative acceleration will pose a hazard to other drivers.
So this is the photo and sketch of my intersection where I have a 16-meter dilemma zone.
These are the photos of my intersection where there is an 18-meter dilemma zone.
And these are the photos of my intersection where I have a 3-meter dilemma zone. And the photo on the right of the spreadsheet is a photo of a car crash that happened on my intersection and the direction that I chose. And it happened because of the dilemma zone and the person did not stop in time and hit another car. And that is our project.